First, let's start with the demo of our SQL AI agent. On the left side, we can see that the database is connected, and we also have the option to explore the schema, including tables, columns, and relationships. We also have a section for sample queries. Let's select one and run it. As you can see, the system starts analyzing the request and generates the SQL automatically. In the response, it provides three things: the final answer, the generated SQL query, and the result data. Now, let's try another query. Top 10 most active patients and their health profiles. The system processes the request and returns the results, showing the top patients along with their health information. We also have a feedback option where users can give a thumbs up or thumbs down. Along with this, we can see detailed metrics such as total latency, SQL generation time, execution time, narration time, number of result rows and columns, reach recount, query type, joins, tables used, SQL length, and where conditions. We can also view the generated SQL query and the result data for each patient. Now, let's ask another simple question. How many records are in the database? The system responds instantly, showing that there are 22,000 records, along with the SQL query and result. This demonstrates how the SQL AI agent can convert natural language into SQL, execute it, and provide accurate results with full transparency and metrics tracking using MLflow. Now that we've seen the demo, let's understand how this system works behind the scenes. First, we have the front end, built using Vite and Tailwind. This is where the user interacts using chat, viewing SQL queries, seeing data, and checking metrics. Next, the request goes through a REST API. Then it reaches the backend, which is built using Python and FastAPI. Here, the system understands the database schema, calculates metrics, and logs feedback. Now comes the main part, the AI agent pipeline, which is the brain of the system. It works in 3 steps. First, the AI converts the user question into a SQL query. Second, the query is executed on the database. Third, the result is converted into a simple, human-readable answer. If anything fails, the system automatically retries. The system can work with any SQL database like SQLite, PostgreSQL, or MySQL. For intelligence, we use Azure OpenAI, which helps in generating SQL and explaining results. Finally, we use MLflow to track everything, like requests, responses, errors, latency, and cost. This helps us monitor the system and debug issues in production. Now that we understand the architecture, let's see how tracking works in MLflow. At the top, we have different sections like Home, Experiments, Prompts, and AI Gateway. This is where MLflow helps us monitor and integrate tracking into our application. Let's go to the home page. Here, we can see the recent experiments. Let's select our SQL AI agent. Inside this, we have the traces section. This shows all the requests, including response, token usage, execution time, request time, and status. Let's open one trace. Here, we can see detailed information such as input query, history length, and which components were called. Now, looking deeper into the pipeline. First, we have the completion call, where the model used is shown. User message is captured. Output response is generated. Token usage and timestamps are tracked. Next, we have the execute SQL step, where input SQL query is shown, output data is returned, row count, execution time, and columns are captured. Then, we have the narrate result step, where the user query is processed, row count is considered, final response is generated. This gives us complete visibility into how the system works internally. So, using MLflow, we can track every step from input to output, including performance, tokens, and execution details. And that's how we achieve full observability for our SQL AI agent. Thank you. Let's see the code and understand how this AI SQL agent works step by step. Imports. First, we import required libraries. We use RE for regex operations, Azure OpenAI for AI interaction, and other modules for settings, database access, and tracing. Azure client setup. Here, we initialize the Azure OpenAI client using API key, endpoint, and version. This client will be used to generate SQL and responses. Database context variable. This variable stores the database schema, which will be dynamically loaded when the app starts. Init agent. Now this function runs at startup. It fetches the full database schema so the AI understands tables and columns before generating SQL. System prompt builder. Here we build the system prompt. This is very important because it tells the AI how to behave. Read-only rules. In this section, we strictly restrict the AI to only generate select queries. No insert, update, or delete operations are allowed for safety. SQL rules. These rules guide the AI to write better SQL. For example, use proper joins, handle nulls, apply limits, and format results clearly. Extract SQL function. This function extracts only the SQL part from the AI response, especially if it's inside a code block. Remove markdown tables. This function cleans the AI output by removing markdown tables, since tables are already handled in the UI. Generate SQL. Now, this function takes the user query and sends it to the AI. The AI returns a SQL query based on the schema and rules. Narrate result. After executing the SQL, this function converts the result into a short, human-readable answer. Retry logic. If the SQL fails, this function sends the error back to the AI and asks it to fix the query. Run query. This is the main pipeline. It connects all steps. Generate SQL, execute it, retry if needed, and return the final answer. Now let's look at the tracing part where we monitor everything happening in the system. Initialize MLflow. This sets up MLflow tracking so we can monitor all operations. SQL metrics. This function analyzes SQL complexity, like number of joins, group by, and query type. Pipeline function. This is the trace pipeline. It wraps the entire process into tracked steps. Generate SQL step. Here we track how long SQL generation takes and store query details. Execute SQL step. This runs the SQL query and records execution time and row count. Error handling plus retrieve. If execution fails, we log the error and retry with corrected SQL. Narration step. This step converts the result into a final answer and tracks response time. Final metrics. Finally, we store all metrics like latency, retries, and success status. Feedback functions. These allow users to give feedback, which helps improve the system over time. Now let's see how results are converted into visualizations. Main visualization function. This function decides how to display the result as a number, chart, or table. Data preparation. Here, rows and columns are converted into structured records. Column classification. This separates numeric columns from label columns for chart creation. Single value case. If there's only one value, it shows a key metric. Chart creation. If multiple values exist, it creates charts like bar, pie, or line. Aggregation logic. If there are duplicate labels, it aggregates values for better visualization. Chart type selection. This decides the chart type based on the query, like trends use line charts, distributions use pie charts. Helper functions. These functions handle numeric checks, formatting, and label cleanup. So overall, this code builds a complete AI SQL agent that converts natural language into SQL, executes it, tracks performance, and visualizes results automatically. Thank you.